Hey there guys, and welcome to part 2 of this design for the phone holder for the Prusa printables flash contest. So last time we got this started, we're making a Lazy Susan phone holder. Didn't see any of those on the submitted designs page. And the other design that I was considering, somebody actually already did something similar to what I was thinking. So we decided to go with this one. Last time, well, one of those things, you probably should have watched the other video before this one, but last time what we designed here was the Lazy Susan part itself. So we got the top shell and the bottom shell. The bottom shell is going to have cages. Let me do these one at a time. 4 different types of bearings. And then we are going to attach to the top of it a phone holder. And one thing that I kind of mentioned in passing is we will also be attaching feet to it. And that's, I might have been very vague about that one, so I won't say that I necessarily, if you missed it, understandable. Anyway, a couple things to bring up since the last time we talked. One, let me switch you over to the desktop camera. Desktop camera's not plugged in. 1 second. Whoopsies. All right, should be coming up here. All right, cool. So I printed the first version of it and printed a cage. Now this cage is the bearings cage, the metal ball bearing cage. And I went with this one to see whether or not it mattered with the airsoft BBs, which are slightly smaller, whether or not they would get jammed up or anything like that. They don't. That's good. Furthermore, I found that this actually is going to need a little bit more space. I gave it 0.5 millimeter before. I adjusted this down to 1 millimeter, this cage on future versions, an extra 1 millimeter on each side, extra 1 millimeter on the radius. Well, extra half rather, total of 1 millimeter. And that should give this plenty of room because I felt like these bearings, when I filled this up, were rubbing a little bit. So that should let them squeeze through, or not squeeze through, but run a little bit smoother. Next thing, you'll notice these captured nuts in here. I added these, and this was on the plan going forward, was to add mounts for the top and the bottom. Whoop, there it goes. And the top one obviously will get the phone mount, and the bottom one will get feet. It's one of those things, just like this, it may not work terribly well, which is why feet may be useful. Now, obviously, you could just do, little rubber feet, just stick on feet. That would 100% work. But I figured making the, I can't remember what they call it on printables, but remixable is what they call it on Thingiverse. Giving some options to remix, to add to the design would be good. So we got those sunk in there. Now, if you're looking at this, obviously that is set up 1 millimeter. I looked at it. It's not going to hit anything. So we got that space in order for that to be sunk in there. On the other side, you'll see those are actually sticking up 1 millimeter. And that would interfere with the roller bearings design because we have that just running along the floor. And we only gave that 1 millimeter of space above the floor. So we're going to go ahead and redesign the roller bearing cage, not even a cage, the spokes for the roller bearings, this stream to get that set in. I don't think we did this on the previous stream, but for this 3-bolt I went ahead and recessed both of these. We might have done that one. I don't think we did the bolt at the top, and the reason I recessed that bolt at the top is that if we use this mounting method here, then we really want this to be flush. So if we're going to put a plate on here, we don't want to have to design around this bolt right here. We want it to be flush. So that's why I went ahead and recessed that. And I made some notes here, so let me just see. I also said something here. I honestly can't remember at this point. I think it may have been that we never put the offset either here or on here. I can't remember where I put it, to make it spin, to give it less friction, rather, to give it a little bit of slop and less friction. That may have been what that offset is that I noted down that I added. So anyway, those are the changes I wanted to get done off a stream so that I would have this printed piece and I wouldn't have to print another version of this with adjustments made. Now, final thing to talk about, interesting, this actually isn't too bad. So without any bearings in here, and sorry if that's loud on the microphone, but without any bearings in here, this is not too hard to rotate. So it's an interesting option to be able to run this without bearings if you don't want to invest the bearings in it. So yep, that's everything I can think of to get you caught up on where I was at. So let's swap back over to Fusion. And I thought I started my music, but it doesn't sound like it. So let's get the music started. All right. So, like I said, a couple things to, well, one fix to do, which is the cage down here, the 623ZZ's cage. You will recall that I said originally you could just run the spokes right through the middle, and now that I've got to adjust this up in order to clear, let's clear the top shell, in order to clear these nuts here that are only half embedded. Oh, that is one thing, other thing that I did. They're half embedded because I added 1mm to the bottom and then countersunk it 1mm. So they're up by like a millimeter, half, something like that. Actually, let me double check that just to be sure. Okay, so they're up by 1.2mm. I countersunk it 1.3mm. So again, ensuring the integrity of the bottom of the bottom shell by not having the nut so close to the bottom edge, and compensating for that by having it sticking up a little bit. It's not a bad idea, and again, it was always going to be, well, I'm not going to say always going to be, but like I said last time, it made more sense that this bearing cage, it probably should just be a lot more streamlined. So we're going to go ahead and take care of that this one. Now, the only trick with taking care of this is that basically we're going to back all the way up here, and I'm just going to go ahead and delete everything. But we're going to have our spokes, our central hub is going to have to go down to the bottom shell. Let me turn the bottom shell back on. So this right here, if we look at this distance here, that's 3mm. That's what we brought it up by. And oh, actually, there's one more thing. Okay, I'll have to remember that for later. There is one more thing I wanted to show you, but it's not relevant to the conversation at the moment. So this is up by 3mm, but the center of the 623s, the roller bearings, that is at 5mm. So if we just took a spoke from the 5mm mark and ran it outwards, that would be above this 3mm mark, which means that we're going to have to also drop that down. It's not that big of a deal, but it is something that I'm mentioning right now. So let's do this. I'm going to go up by, actually, let me skip this too, and I'm just going to delete everything after that, because we're just going to completely redo this. So 5mm is our center point on the bearing. So let me go ahead and call that. Bearing center plane. Okay. And one of these things where we have an option on how to do this, and so if let's look at this really quick. If we're going to go down in order to intersect with this hub, then what we're going to have to how this wants to be printed is actually the top edge here is going to be face down on the print bed, is how that's going to want to be printed. So while I would normally want to do like nice little circles, because circles are more aesthetically pleasing than squares, we want this top part to be flat. So I have an option, we have an option at any rate. We could sketch on this plane and use this 5mm offset that I just put there as a reference, you know, so I don't have to go back and delete it. But that would allow us to do something like this. Let me just sketch it up so that you're seeing what I'm saying. So we could sketch something like this, where we cut this circle off like this, and then the connection point, let's call it this. Actually, it wouldn't be that really. We'd be better off here just for print quality purposes. That way this is flat all the way across. If this line is above that, then we've got overhangs to deal with, which is not that big of a deal on a curve like this. It's not going to print terribly horribly, but it'd be better not to have any overhang. So we could make a round shape like this if we wanted to. And then the only trick is that this random point right here, which I'm just drawing in, pretend that's centered, that just has to be centered on this 5mm part. That way, this random point, which is connecting through to the bearing, is in line. That's the only thing we'd have to worry about. And again, we could do it like this, or we could design it top down. It really comes down to preference. I think I'm going to design top down first, and then maybe we come back here and do this plane, and we just figure out how we want to go about getting that implemented. But the reason I'm starting from the top down is that getting the hub situated first is the easiest place to start. It gives us a reference point. So let's go ahead. We're just doing the hub right now. We're not going to do the spokes just yet. Again, this is at the 5mm part, so this is, it's technically speaking, maybe a little bit below where we're going to want to end up. For example, if we have 3mm thick spokes, those want to be centered on 5mm, which means that half of 3mm, 1.5, would take us up to 6.25, or 6.5 rather. I don't know why I added the extra 2.5 in there. I divided the half in half again. So anyway, we'd be at 6.5, would technically be the top of this hub. We can go ahead and adjust that later. We can just go ahead and extrude the top of it up to match the spokes. Or we could, because I already named this bearing center plane. No, okay, I take it back. I know I'm being wishy-washy here, but we are going to make changes because it makes more sense. So let's do it like this. So the roller bearing diameter divided by 2 gets us to the center point, plus wall thickness divided by 2. And that will get us our 6.5, as you can see down here in the description. And this is also now parametric, which is nice, although frankly completely unnecessary because we're not going to be changing any of those parameters. So that is now the very top, as far as I can imagine, of what we're about to build here. This cage. It's not really a cage because it's not actually containing the bearings themselves. It is the spokes, the hub that's going to be... turn you off a second so I can click this. And I just did not complete that sentence, and that's okay because you know exactly what I'm talking about. Alright, and then again, last time we decided to offset this a whole bunch, a lot more than I normally do for 3D printing, because this wants to run as freely as possible around the central hub here. And let's turn this back to blue, just for my sanity, because the other one was blue. And now, again, coming off this way, I'm going to go ahead and do a tangent plane, just so that I'm not working from the center and have to offset. So let's just grab an origin to reference. There we go. And it doesn't matter which one we're really referencing because we're only doing one and then patterning it around. Sorry. One other thing while I'm talking about patterning around, the other cages, I didn't say this, but they don't necessarily need to be 3 spokes going all the way around. I want to just have that said for the record. And they don't need to be 3 spokes. They could be just 1 spoke because all it's doing is positioning, and there is no lateral, there should be at any rate, no lateral movement of the bearings towards the inside of the ring. And therefore, it's a bit of a waste of time. I mean, waste of time may not be the correct way to say it, but it's not accomplishing much, let's say that, to have, yeah, I guess that would be tangent to that line because we already compensated for it. Regardless, it's not accomplishing much to have the extra spokes because they're not actually bearing the weight. They're not making, you know what I'm saying? They're not stopping anything from going anywhere. You could just have the one spoke to keep the outer ring in place, and then you'd be good. So it's a little bit of extra plastic, but it's how do I say this? It's more reassuring to have the extra spokes holding it in place. And I'm just trying to think. We had a number, and I already deleted the other one. So the question is, where was that number, and do I need to bring it back up? And the number was how far out this spoke extends out towards the wall. And I think I will go ahead and redraw that in. Let's hop back into, well, try to hop back into the sketch. Hop back into the sketch. Okay. So here's our inside wall, and as you will recall last time, we did one of these. Yeah, I'll just use that. Did one of these. That's centered. And then you'll recall these were coincidence and quinky dinks. And then we had the 10 millimeter bearing there. And this was 4 millimeters wide, as I recall. And this is just our mock-up of where that bearing is. And that bearing, I can't recall if we gave it a little bit of breathing room here. Whether we actually put this in here like a 0.5 millimeter from the wall or not. But we did something along these lines. Actually, I seem to recall us having another circle here because we had this tangent to something. However, that should be unnecessary at this point. It should be sketchable like this. So, stop. Stop. Don't move. I don't want you to move. I just want you to construction line. Alright, so that's how long our leg is going to be, our spoke is going to be. The question is, I'm kind of curious whether or not, or how this is going to work, I'm going to say, rather. You are on the wrong side. Everything was upside down. That is unfortunate. What if I do this, is my question. Let's turn the bodies back on to see what's happening. Yeah, okay, it will work. I just have the sketch on the wrong side. We are on the bottom right now. We want to be on the top. And then that is front. So actually that is in the right place. Control Y. So you... Huh, yeah. You are... Remember... Yeah, okay. Remember when I said it didn't matter this tangent plane, where this tangent plane was? It's going to matter for us now. Because we have to line it up with the other one. Alright, there we go. So, yeah, except for when we flip it upside down, of course it does that. Okay, that, we are still looking, yeah, the top's still there, so that's 5 millimeters. And again, I could just actually tangent this to that, but it's better because we're most concerned with this spoke being centered on the bearing. It's better to just call that center of bearing instead. Actually, because I've just worded it that way. Roller bearing diameter divided by 2. There we go. The other thing, actually, that I should probably do is this should probably be 4 millimeters. In which case, we're going to have to redo our math. So, let us change that to 4 divided by 2. And the reason we're doing this... Yep, that's still in line. The reason we're doing this is because on the back side of the bearing, and here, actually, let me just swap you over to the camera. Little interaction here. So on the back side of these bearings, when we take this this is a 3mm bolt right here, M3 bolt. So you can substitute this for the plastic that we're about to print. If this is 3mm all the way through, then it actually just goes straight through by opening it up to 4 or 5mm on the spoke. And actually, I may even do 5 just for the heck of it. By opening up to 5, that gives us more meat for it to be pressed up against. Again, imagine this set going to the hub. So this part extends to the hub. This is 5mm, 5.45 technically on these button heads. Actually, button heads, yeah, button heads might still be 5.45. Regardless, might be 5.5. We then go down to 3mm to get through, and again, that's the clippy part. I was talking last time that was going to be one of the snap-on features. We'll have a snap-on joint. The alternative is we could use bolts, screws, and come through into the plastic, leave a 3mm hole, which will be slightly undersized because 3D printing, and then just tap threads into there. That is an option. That is absolutely an option. We'll see what happens. The snap-on feature sounds funner. It sounds more fun. However, the problem with the snap-on feature is that for features this small on an what do you call it, an FDM printer, it's not going to be terribly precise, is the only problem. So it may be better just to take bolts and tap them on there, but we're going to attempt it with the snap-on feature instead. So let's hop you back over to Fusion. I'm getting better at not forgetting here. And now let's get this spoke done. From object and distant. So it's one of those things. The two objects thing, depending on the... Okay. Where is... Okay, it's not showing it here, but sometimes they give you like extent. They give you... Oh, no, it's not there. They'll give an extra toggle box down here, whether you want the closest extent or the furthest extent. It's not giving me that, so I've got to come here and kind of look at this and say, okay, I'm pretty sure that's connected right there. Yeah, that is connected there. So it did come all the way to here. I have had times, especially when cutting into an object, for example, if I had text here and I was trying to engrave text on this, I've had times where I've said start from the face of the object, and it will do it some parts of it, but not others. It's a bit weird. So just one of those things I'm telling you so that you can watch out for it when you're designing your stuff. And actually, I'm going to go ahead and give us 2mm here, because the snap through functionality, I want to leave a little bit of space for. So if we come a millimeter out the other side, actually, let's go 4, because again, these bearings don't necessarily need to be so close to the edge. So if we go 4 and then we're out by 2 or 3, we still have 1mm of clearance here. So we should be good. So let us go ahead and... How do I want to run this? Again, I can come down here. Let's spoke tangent plane. Spoke tangent plane. I could reuse this and then again extrude from object here. That way I don't have extra planes that I'm not going to use, and I think that's probably what I'm going to do. So we're going to go ahead and actually let me do that too. I was talking about this before we started, and then I forgot to actually do it. So when I first started drawing, okay, stop being silly. Finish. Double click that. There we go. When I first started drawing this, you saw me do this circle here, and then I went and put the other circle down here, and I was like, oh, whoops. That's because what I meant to do. And again, we want to keep this flat for 3D printing purposes because we're designing for 3D printing. So we want, when this gets printed, to not have any overhangs, and therefore this extrusion here is actually going to be all of that as well. So you can see this is the D shape, and we're doing that only because it's going to be printed like this. So with that explanation out of the way, our next problem here actually is back to 3D printing and small features. So this feature is going to be small, and therefore it's going to be difficult to print. Plus, this is going to be, if we center this right here, so let me just do this so that you're seeing what I'm talking about. If we center this, oh, that's funny, it's not giving me actual circle, center circle. So let's draw that line in. So if I do my 3mm snap feature here, you can see that's going to be suspended in the air, printing from here. So let's flip this over again, just in case you have trouble visualizing. When this prints, it's going to be floating in the air here, which means that it needs supports, and supports is going to make it rougher on top of the fact that it's already a bit of an a very demanding feature. So at this point, I'm actually thinking that we will go with that second option that I was talking about, which is the self-tapping hole. And let's see here, turn that off. There we go. So we will go ahead and just put a hole in here, and you can thread some bolts into it in order to attach the bearings. That is how we will go about it. And we can make this, we can make it any number really. So let's just call it 10, minus 10. And the next question is that wall is a little bit on the thin side. Yeah, it's only 0.5 millimeter. So we're going to want to make that bigger. And I just keep on adding ands. We're getting a little tall here. Now, I don't think it's actually tall enough because our upper limit is 10 millimeters. So right now we are at 5 plus 2.5, which is half of the 5 millimeters. I think that's what I made this. Did I make this 4 or 5? All right, we'll come back here and find out. Bearing to center plane. I made it 4, didn't I? Let me edit feature. Please let me edit feature. All right, I left that at 4. So we're at 4 divided by 2 is 2 plus 5 is 7. We just need to get below 10, and that means that we can have up to 10 millimeter because 5 and 5 is 10. So I mean, we could, the point being is that we could have a very large spoke coming out here. So we will just update this to, let's say, C6 sounds a little big. 6 is quite thick in terms of plastic. It's going to seem a bit bulky, so I'm going to leave it at 5, and we're going to call it a day. So at 5, this should now be between here and here. 1 millimeter, it did not update. Let's see here. Oh, and actually I know exactly why. So let's come back here. And we're going to do this. 623. I can't start with letter. So spoke, we're just going to call it spoke dia equals. And we just got to throw some extra parentheses in here, if I recall correctly. Should work. It did not work. I could have swore I've defined these inside before, which is a little bit funny. Alright, we'll define it outside. That's fine. Change parameter. Actually, can I retro this? It's one of those things I try to define parameters before I use them, but this is a situation where I can't, so we will attempt to do it this way. And let's just double check that that's 1 millimeter now. On the outside, it is 1 millimeter. And now if I come back to, actually, Let's think about this. That hole's not centered on that, is it? No. Okay. I don't think it is. So, therefore, we come back here. Basically, I was wondering whether or not we had to... Huh. Why you got a problem with me? There we go. Okay. I was trying to figure out whether or not we needed to make any other adjustments here, but we should be good. So, that is 30 minutes in for the record, and that was a good bit more time than I expected to spend on this portion, unfortunately. But we are now done. We just circle pattern this out, and that is the update to this cage hub thing. I mean, again, we'll just leave it at just okay. Adjust was not the correct option there. Alright, there we go. And actually, the one thing I will do is back to I don't want any scraping here, so I will just offset this by 1 millimeter, because all we've got to do is be on the hub. We don't necessarily need to be, you know, all the way down on the floor there. So long as we have at least enough that it doesn't slip off, which it shouldn't slip off because the top shell should be holding down in place. So for all those reasons, we should be fine. This hub shouldn't go anywhere, so long as it has just a little bit of grab on the central hub of the bottom shell. So that gets us onto the main point of this episode, which is the phone attachment. Yay! New component. Phone attachment. And again, the reason, one of the reasons why I have these little mounting holes on the top here, I've added these little mounting holes on the top here, and let's just really quick show that. Oh, where did they go? Tell me I did not. Does the bottom shell? Oh goodness. Okay. Either this account did not sync or I did not hit the save button on, and by account I mean this instance of Fusion. Huh. Okay. I will add those back in. That is very unfortunate. Okay. Let me resync this. Hey, look, there's stuff over here you don't know about. Resync. Versions. 623. Oh, I see what happened here. Okay. Scary moment averted. Scary moment averted. Is this the phone attachment? Yeah, it is. Okay. Now I know where that is. We were back in the timeline. Okay. Good bunch of men. Okay. And there's my... Nope, that's their cage. Where is the phone attachment? There's the phone attachment. Let's move you to the end. Okay. We are just going to delete you and recreate you because you don't want to move. Alright. There we go. Everything is now back as it's supposed to be. Anyway, what I was going to say before disaster nearly struck there is the reason, again, that we have these instead of me just hard designing the phone mount into the top lid is so that people can make their own phone mounts. That is the idea and the purpose, so that this is extendable and other people can have fun with it. Otherwise, I could just glue this, I mean, not even glue on, but, you know, design it directly into the top lid, and, you know, that would be a thing. Obviously, if you want to get technical, that would make it more difficult to print, technically speaking, and therefore it is better for it to be detached, but it doesn't necessarily, but it is an option, is what I should say. It was an option, and my reason for not doing it is because I prefer to have the option available for other people to create their own phone mounts. There you go. So let's toss these in. These are the ones that we're concerned with, and let's do a slot. Slot, and we could do center to center. Center it there. Radius this out. Whoops, not that kind of radius. Like that. Just 3mm is fine. Again, 3mm is my go-to number. So after this is assembled, then you can slap. Actually, no. We do need to leave this hole open. Good thing I thought about that before I said something that made me sound pretty stupid. Alright. You will have to attach this base first before you attach... before you attach the top shell to the bottom shell. Because all these bolts are right here. And you won't have access to it. So that is something important that I'm going to have to keep in mind to make sure that everybody is aware of. 0.5 is more than enough just to make sure that we're clearing. And let's get this popped out. And just as the mounting plate, that really wall thickness is fine. And what color do you want to be? We already used all these colors. Let's see what other colors I randomly have in here. Plastic opaque, orange. Have we used orange yet? Yeah, we used orange. Brown. You are now brown. Cool. All right. So, again, this is going to be a two-part mount, and the first part can be... Actually, do I want the first part built into this? So this was one of those design decisions that I did not make yet. Actually, let me even do this. New component is what I should have done here. Back to just keeping everything organized, and in order to introduce what do you call them, joints, it's easier to have everything as their own components. So there we go. The mount is going to want to be flexible, like pivotable, I should say, in the what would you call that, the YZ basically. So if we're looking at this Z-axis, actually that would be X. No, I'm looking at it wrong. There you go. It was Y. So going from Y minus to Y positive here, or Y positive to Y minus, depending on how you're looking at it, we do want it to be able to tilt this way, that way, because we're assuming that you're not always looking at your phone straight on. So we do want to build a pivot into this. So let's go ahead and do that. So we're going to call this the attachment plate. And we'll activate it. And then the question is, how do we want to go about defining? Because we could just grab, you know, this plane here, this origin plane here, but that's not very well defined. So let's do this. We're going to go axis through cylinder. So we got an axis here. We can now go plane at angle there and 90 degrees. And then the next question is, do we just want to design on this one? So let's call this center of through hole, and that is the Y center of through hole. So do we want to just design on this and then offset it, which is completely reasonable, or do we want to more specifically, and I think we will, do the same thing over here? It's one of those things. I will say right now, and I've actually said this a few times before, but one of those things, in case you don't watch all the episodes, there are 1.5 million ways to skin a cat, and there's not necessarily a right or wrong way all the time to design something. A lot of the times you're going to design something once, and that's going to be it. And if we're from the front, this is the Y left mounting hole. You're going to design it once, and then you're never going to go back to it again in many cases, and therefore it doesn't necessarily matter how you do it. So this is a bit obtuse the way I'm doing this now, and not even necessary, or at the very least, if not necessary, then more convoluted than it needs to be. However, it does make me happy, so there's something there. Alright, so we have, I really don't like that projection. Let us come back here and grab a different projection. I am going to grab that edge, and then I'll just fill it in. One of these things, projections always break anyway, so while that's probably not the best projection, it gives me the fewest amount of things that can break it. It's only 2 edges, as opposed to when I took the top face rather, as my projection. That was this circle, that circle, that circle, this edge, that edge, this face over here, that face over there, that edge. You know, it gave me a lot of different lines there that it could get screwed up and would have to be redefined. So that is why I just did what I did and grabbed those 2 edges instead, because I can always come back and it's a lot easier to re-project those 2 edges. So with that explanation out of the way, let's get this thing drawn. U tangent, U tangent, U perpendicular, U perpendicular, okay. And then our mounting hole here. So back to my general design design philosophy is, if you start out with 3mm M3 bolts, then you generally speaking should just continue using M3 bolts for everything, because that makes it easier to source bolts for the project. But this being a hinge, I kind of want to go up to M5s, at least M5s, if not M6s. I mean, M6s is probably overkill, but so at least M5s. Yeah, I think it's worth it. So we will make this connected via an M5 bolt, is the conclusion I've come to. And this right here, this height, is probably not going to be relevant. Yeah, I don't see this being relevant. So let's make it as small as possible and tangent that there. And we can go ahead and pick that up. So this here, body, and we want a symmetric, that way this is still on center, whole length, and I'm happy with wall thickness. I think I'm happy with wall thickness. Whoops. We could make it a little bit thicker because it is a hinge holding the phone. Yeah, I feel comfortable with this. So there's one hinge, and yeah, actually, you know what? I take it back. Already changing my mind. We're not going to make this tangent. And the reason we're not going to make this tangent is because I'm looking at this right here, and this looks like, okay, yeah, it's only 2mm, which means that on the part it connects to is going to be the what's called on the other side is going to be thinner. The hinging part that connects to the bottom mount of the phone is going to have less space to swing through, and it's going to have to be thinner, is the reason there. So let's go ahead and give ourselves another 5mm. No, 5mm too much. 3mm, 2mm. I mean, it's 2 plus, if I do another 2, that will be 4 overall. I feel comfortable with that. So that's going to be our offset there, and now that is there. So now we have a little bit more space to bulk up the connection point over here, and I'm pointing here, but it may be better to do it on the outside. So let's go ahead and mirror that over. Feature, mirror, the center, and we actually want to use this Y center through hole here just in case stuff move. Again, that's why I made all these extra planes here, is so that we have stuff relative to the features of our object here as opposed to relative to generic origin right here. So that gets us there, and now we can move on to the next part, which is the bottom what you call it, bottom phone mount, I guess is what I'll call it. It's a terrible name, but it will work. It'll do, donkey. It will do. Now, again, we have an option on how exactly we want to position the start of this. The first thing we're going to be drawing is the hinge attachment. That way we know where we're at. And then after we get the hinge attachment, I'll go ahead and draw the rest of the, or sketch, however you want to say it, the rest of the bottom of the phone mount. So, alright, I think what I'm going to do here is I'm going to hop back over to this and just throw a new plane here and call that side of hinge. Side of hinge. Alright. And now we'll hop back over here and use that plane as a reference point. And we just got to get a projection here. We can leave this guy as a solid. Everything else will be construction lines. And now here again, I can go ahead and make this a full 3 millimeters of space here to give us a bit more meat. 3 millimeters, no, I'm happy with that. I was going to say, it's one of those things, it looks a bit bulky in comparison, but it is the wall thickness that I like, and therefore it's what we'll be keeping with. Now, this one here, you may recall, let me just hit this really quick so that my brain can catch up. The other one, I felt like I needed some space for the extra hinge space here. Again, this is why I lifted that up, so that I can make this a little bit bulkier. But this one, I don't see any reason not to have tangent. So that's what we're going to do. And we can go ahead and extrude this guy out. And I'm just turning that guy back on so that I can see what I'm doing. And what? I've already forgotten. Did we do 5 millimeters? I think we did 5 millimeters. I should probably like make this a variable, like hinge thickness, but I'm kind of doubting that it's going to be a serious change. Like I am doubting I'm ever going to change it. So the next thing to discuss here is right now, this is going to be, for example, PETG on PETG sliding, which means that our hinge is not going to be terribly effective. We can go ahead and put alignment, basically features on this, and then it would snap into place. You wouldn't have fine adjustment abilities, but you could have, we could set it every, I don't know, 5 degrees or something like that. We could attempt to set it every 5 degrees or something like that, and basically ring this hinge and that hinge with marrying features so they piece into each other every 5 degrees. And that would give you, 5 degrees may not even fit. It may be one of those things, the features may be too small and therefore not really printable. Speaking of printability, right now this bottom hinge prints just fine. Prints relatively fine. I don't worry about holes for bolts. It's one of those things where if you need to drill those out yourself, then you can. Otherwise, it's might be a little tight, but I'm not terribly concerned about it. It's not going to affect the overall usage. Although you could make the argument that not drilling them out and leaving them tight solves this problem we're trying to solve with this hinge rotating freely. The bolt would actually keep the phone positioned in the way that you're trying to set it up. So that is one argument to not draw them out. But the point being, what I was getting at is this prints just fine like this. The bottom attachment plate, it will print straight up and down, no problem. This guy right here, though, might be a little bit of a problem, or may not print terribly well. And what may end up happening is we won't be able to print it. Let me just hop here and get this positioned. So if you imagine some kind of holder heading this way, we probably won't be able to print it like this, which means that we'll probably have to print it like this, and we'll have the design like this so that this is flat. The right hand side here where my cursor is flat against the print bed. That may be how we're designing this moving forward. We do have, again, this overhang right here. In that case, if this is, let's rotate again, if this is now the print bed, then we have this overhang here. But as I stated before, I'm not too concerned about overhangs on round parts. I only avoided it on the other one because it was so close to where it was just round all the way around, and it wouldn't look terribly good from the top view is my biggest problem. Whereas this one, any overhang artifacting that happens here when we print it will be on the back side of the hinge, because again, I'm designing so the phone sits in front of these two boxes that I'm drawing right here. So the phone will sit up in this area, in which case you will never see the artifacting on the bottom side of this hinge. So it's not really an issue. Well, I mean, it's a little bit of an issue, you know, depending on how OCD you are, but it is not something that's going to be a deal breaker that's going to look really ugly. You're not really going to see it. So that's where we're at right now. And now we can just do a simple phone mount. And I'm saying simple because, frankly speaking, one thing I should say, actually, I did tangent here. You'll recall back on this sketch, I did tangent. I only was able to do that because I knew that this is bigger than that. Or I should say that the other way around. This circle right here is bigger than that one. If we made this tangent to that circle, then as this hinge rotated, it would scrape against this rotation point right here, which is not a deal breaker. It's not something that's going to stop it from working necessarily, but it would be obnoxious. This, we got a little bit of clearance before we do the top mount here, so we're good. So all that explanation out of the way and thought process, let us go ahead and mirror this. Mirror, feature, and we'll go back to the center plane on this guy on the attachment plate. And again, I leave it at whatever the default is what I should say. Again, it used to be that optimize was the default in Fusion, and I just left it at that until something broke. I don't know why it changed to be adjust is the default. It's one of those things, probably could go into patch notes and read patch notes and find out why. But for the time being, I'm not terribly concerned. Now, after with long ado and finally and etc., we can now draw this phone holder itself, and I will go ahead and use this center of the through hole because that's going to be centered to everything else, and then I will just symmetric extrude out two of these two hinges. So let's get one of these hinges as a reference point. Bodies, turn them off. Let the bodies hit the off button, the not visible button. And we don't need those can just be construction lines. And it's one of these things, I am not a terribly artistic person, and therefore this is not going to be a terribly artistic phone mount. I say that, and I should probably give myself a little bit more credit. It's not necessarily that I'm not very artistic, it's just that when it comes to doing, let's see, how do I want to word this? I am only artistic basically in things outside of the computer. When it comes to things inside the computer, I just have not spent any time trying to figure out how they work. So I am not terribly concerned about how this looks right now. It's supposed to do a job, it's going to get that job done, and other people can remix this and make fancier mounts. So this is the general shape of the bottom. Good. We're all on the same page. The question is, how do I, and it's the perpetual question. So basically sometimes I will get this general shape and then I'll do one of these minus wall thickness, you know, and then I'll just toss these guys in here. That is one way of doing it. The other way of doing it, which I also do sometimes, is to overlap two boxes, and then I'll do, you know, for example, collinear, and then wall and wall thickness. Again, 1.5 million ways to skin a cat. It really depends on what I'm thinking at any given time. And today I'm thinking that we're going to do offsets. That is what I'm thinking. So now we need to start taking some measurements of phones. So the smallest that this is going to be able to hold, well, let's take a look. And frankly, I don't, I have a Droid Bionic, which is probably not a phone that anybody uses at this point. So first off, let me just say, I'm not designing for somebody to mount their Nokia onto this thing, okay? Nokia's, I mean, if you really want to see Snake play itself or something like that on your Nokia and you need a phone holder for that, that is you go ahead and make that one, okay? That's a rather specific ask. I do have a Droid Bionic, like I said, but that is with a project right now, and I do not have access to it, so I can't get that measurement. So this is a Galaxy S7. Let's go ahead and turn the camera back on, just for the heck of it. This is my old S7. I'm guessing this is on the smaller end of smartphones at this point. The only thing smaller than this that I can think of is an like old school iPod, or actually no, the iPod Nano would be smaller, but in terms of stuff that would have a screen that you'd actually want to be looking at constantly, something like an iPod might be the smallest thing. And I don't even know if anybody has iPod. Well, actually my brother, I think, still uses an iPod just for certain situations where he doesn't want to have his phone out. But the point being is that this, we're going to call it 69.5 that I'm measuring here. If we just make it 60 millimeters is our minimum opening space, I can't imagine anybody having real complaints about that one. Again, the more likely complaint is just the phone holder, it does not look terribly interesting. So if we there's a couple ways we can do this, and actually there's something else that I should do. That was the minimum. The other option is getting the other thing we kind of want to keep in mind is a maximum. So this is my current phone. This one's like 85, so if we call this 90, so if we called our overall 60 to 90, okay, is the dimensions that we're trying to, and it's one of those things. If you want to put an iPad in here, or a what do you call it, an Amazon Fire device, you know, it may be one of these situations where, again, I just say, enjoy designing that one. And the other thing I could say is I could look at other designs that are out there right now, and they have mounts for phones that you could probably actually this is, sorry, okay, I know I hop around a lot and my brain just goes all over the place. It occurred to me that rather than doing this very specific mount, I probably should have just grabbed this GoPod mount that I have over here, because GoPod mounts are pretty universal for stuff, and just had the GoPod mount as the option. That way you had more likelihood to, sorry, I don't have this in screen. This is a GoPod mount that I'm printed for the lift pod that you're sitting on top of right now. And GoPod mounts are pretty ubiquitous, and there's probably a ton of just drop-in phone holders and iPad holders that fit directly into a GoPod mount. So this is probably what I should design as an attachment on there. Yeah, okay. Yeah, well, alright. So here's the argument. If I do this, then I don't really, well, man, I was going to say I don't really have an incentive to make another one, make an actual phone stand, because I can just say, yeah, screw it, you get your own phone stand. But that obviously does not fly. So... Why do I gotta make decisions? You guys make decisions. You do that. And the last problem that I'll bring up is that obviously the GoPod mount is centered underneath the phone device, tablet, whatever. Our through hole is also centered. Now, that doesn't necessarily matter. We could off-center this so that when the lazy... Actually, let me grab the Lazy Susan really quick. We could off-center it like this. So when you spin, it's spinning a little off-centered, but nobody really notices. Especially because any phone or iPad is going to be like this, so the center of balance is going to be more or less here anyway, dead center of the Lazy Susan to begin with. So I'm probably whining and complaining for no reason, and we are going to go ahead and replicate a GoPod mount and undo all the work we just did. Alright, let's switch you back over to Fusion. And actually, you know what? I am going to BRB really quick. Text. BRB 2sec. Okay. Enjoy the music for just a second. Okay, so I am back, but it looks like the music died, which is fascinating. So I am attempting to fix that really quick. And I'm curious as to why that happened. So let me toss you back onto the desktop, my desktop really quick, just in case I pop anything up onto the screen that I don't particularly want you seeing. So let us see. I'm guessing this could be, okay, my headphones, I wasn't sure if my headphones desynced, which is why I'm not hearing it. The streaming software says that you're not hearing it, but the streaming software has also screwed up before. So I'm opening the music app back up really quick and hitting the play button again. Alright, cool. I've got music back, you should have music back, so let's get back to designing. Alright, we can get rid of this now. And let's back up. So, attachment plate. What I'm going to actually do here, rather than get rid of all my work, is I am going to go here. I'm going to, do we want another component or do we want a subcomponent? So I'm going to do something here called boundary fill to create a new component. I just don't know whether I want that as a subcomponent. Where's boundary fill? Boundary fill. So we'll click that and then click that. And yeah, we're going to go ahead and make that a subcomponent. And I'm going to call this Gopro mount. All right. So now we have this GoPro mount, which is based off of effectively this body right here from the attachment plate. So if I turn this off, you'll see it's still visible because that's the GoPro mount. And if I go ahead and forward through all those other things, you can see that they're not actually here on the GoPro mount. So in case you didn't know that trick, that's a new trick for you. And now we'll come back over here and adjust this guy to fit the GoPro stuff. So the GoPro, let's see what kind of, because I do not remember what kind of mount attaches to this guy, or what kind of screws rather. Okay, that is still a 5mm. That's good to know. It's a 5mm and it looks like it is so I'm going to make this 8 point. It looks like 8 is probably the correct number, but I'm going to make it 8.5 from the base is where I'm going to put the mounting hole. And then if I hop you back over to the physical camera, we'll go ahead and make it this same fin shaped. So we're going to have a vertical edge here, and then we're going to go ahead and taper it back there. Draft it, whatever you want to call it. So back to Fusion, and let's make these adjustments. So this is going to, so the first question we want to do, the first question we want to answer is, and I'm going to go ahead and toss, actually let's toss that in here. Just a bottom of plate. Construction line. Construction plane rather. Bottom of plate. And I'm going to go ahead and slide this back here. Just to get it way back. And we will go ahead and sketch on that guy. And the front is this the front here? Yep, that is the front there. Good. Just wanted to make sure I was facing the correct direction. So a couple different ways we can do this. One, we could bring this all the way out, and I'm just drawing a line for the heck of it, but actually, let's go ahead and do this. So could do something like this and extend a full circle out this way. I don't particularly like that. I think I'm just going to do a circle here, and however big I make it is basically going to be how big we need for this, which looks like 16 and 20 are two measurements for width and depth on the GoPro mount. So if I call it 25, I will be happy. So that will be the diameter of 25. And I think, yeah, okay, that does come out this way. All right. Maybe I don't do that this way then. Let's go ahead and depth of 20 and width of whatever I just said. 16, I think I said. All right, we're going to call it 16 and a half. So this is the mock-up of our GoPro mount. Again, we need to clear this guy. Let's go ahead and drop a center point in here. And we don't need the full center point. We'll just drop an actual physical center point into it. That missed. All right. Oh, and actually, no, that works. That works. Because I was thinking about going tangent to this anyway. So we can just put the hole right there. And that is the outline. And we can now go and see what this looks like. And that looks terrible. So we are going to just, I think we can do a 3-point arc, probably. Which way do we want to do this? Yeah, let's do it. Let's see what the 3-point arc looks like. Again, 1,500,000 ways to solve any of these problems. If I go center point, 3-point arc, what's that look like? Yeah, let's try that. Let's try that. There. 2. It's funny because obviously that's real close. I might want to. It's one of those things that will be hugging the front of the hugging the front there, but who particularly cares? Actually, let's check this out really quick. That's another question because we don't want it hanging off of the Lazy Susan. So where's my base? Top shell, bottom shell. Okay, no, we're way smaller than Lazy Susan still. Just one of those things. Wanted to keep a sense of perspective. So we're still good. Huh. Yeah, we may actually be fine here. So, yeah, I'm gonna say we're fine. All right. That, well, it's one of these things, right? Back to, at this point, I may as well just do this. If I'm gonna cut the corners anyway, then may as well just use the circle to keep it simpler. Design decisions. Alright, let's go with it. We can always change it later. Distance to object. Cool. And now we will go ahead and make this construction plane specifically on the Gopro mount because this is one that I'm using specifically. Actually, I take it back. We are going to go back to the Y center. And the reason I'm doing that is because if we look at the Gopro mount in physical, we have a center fish here. So we can go ahead and extrude that a center fish. We can extrude that out the 2 point. This is saying 2.7. I wonder if this is in inches. What's that fraction? Look like 7/64? That's not a fraction. 1/8. Okay, so maybe these are a nominal 1/8 inch. Let's check here. Okay, you know what? There's something called the, well, yeah, I mean, that is now that I'm twisting it a little bit, it is getting up to 1/8 inch. What I was going to say is there's something called the internet, and we may just want to Google really quick. GoPro mount specs. Let's see. I misspelled specs, but shouldn't really be a problem. Let's see. I'm trying to see if there's any links on this first page. Doesn't appear to. So let me grab an accessory really quick and see if I can't get a spec drawing. Yeah, spec drawing on a product page for a commercial project, or a a end user product. Yeah, I'm not gonna find anything here. All right, I am going to give up for the moment and just go with that 1/8 of an inch. That I've decided these are. Each of these fins are, I'm going to say 1/8 of an inch, and we are going to leave it at that. So let's get that drawn. One of those things, if it's off by a little bit, it's off by a little bit, and probably it still works. Probably. So we are going to go ahead and project that. And I'm going to go ahead and project that so I know where to stop. So we can turn the body off now. These are going to be construction lines. And then we're going to drop our 5mm hole in here. I'm going to go ahead and I was thinking of doing the hex nut, the captured hex nut too on this pane. It's one of those things. It saves me one sketch object. It just pollutes the sketch pool a little bit, which who really cares? Yeah, who really cares, right? So if we're going to be printing vertically, then we want our overhangs to be like this. We don't want a flat overhang. If we're printing it up and down like this, we don't want the flat overhang on this side. We want the flat overhang. We want the flat side going with the print. So that explains that. That's why I'm positioning it that way, and we'll go ahead and make sure that is perpendicular. And now I just need a measurement for an M5 nut. Let's see, and I'll pull an M5 bolt out while I'm at it. So here's my M5 nuts, and we said this was, I keep on forgetting my numbers, about 16. So I'll pull all my options right now are 16 or 20 for the M5 bolt. I don't think I have any other sizes of M5 bolts, so I will just grab the M5 by 20. Alright, M5 by 20, got. Okie dokies. Next thing to mention. So the next thing that I'm going to mention is how we tighten this down. Because we don't have a real good way of doing that with just a bolt, with a button head bolt. I should say, if we had a hex head bolt, then we could just stick that on a, let me just switch it back over to the camera so you're not staring at dead space. So here's my M5 by 20. Here's my M5 nut. Now you know what we're looking at. This M5 nut, in theory, fits right here. It does. And it actually feels a little loose. Let me double check the M5 bolt. Yeah, that's definitely an M5 bolt hole. So my M5 nut evidently is a little under the M5 nut that this is designed for. Otherwise, it's designed to be loose. I don't know why you would bother. It's one of those things, 3D prints, you want to sink in normally to make it snug. It's one of those things you're not going to break the print by snugging it up. So I'm not sure why that's loose. But point being is, I've got this little thing, which I can't remember which mount this was on originally. But this was a tightening, what you call it, for one of the Gopro, not GoPro, but lift pod mounts that I had, and it just self-tap threaded on and tightened down, which worked okay. But the point being, and the reason I'm having difficulty here, is this bolt needs to go this way and be tightened down like this, because our capture nut is on the other side. So this obviously is not going to work. So basically the way I have fixed that in the past is I'll take because I don't have hex head bolts. If I had hex head bolts, you would just, and I do have hex head bolts for other sizes, just not this one, but you would take this hex head bolt, feed it all the way through so that it's inside there, and the hex would keep it locked in. It would be sunk into a hex head feature on the inside of this shaft, let's say, and that would keep it in place. If I did the same thing with this button head, it would still spin freely because there's nothing keeping its orientation. But if I take an M5 bolt here, thread it all the way down, then that acts as an M5 bolt head at that point, or hex head bolt at that point. Let me just drop this all the way down so you can see it. So now I've effectively made an M5 bolt with a nut head. And the other thing that you can do is you can put a backup screw on this. That basically just 3D print a set screw is all you really need, because going in one direction is fine because the bolt wants to go in that direction, the nut rather wants to go in that direction. It will just eat in and it will work. But if we reverse that, now you can see how the nut may want to start traveling up. But if you have a set screw in the back there stopping this from separating, then that's not going to happen. So that may be what we need to design here. And it's one of those things, chances are that actually probably already exists somewhere on Thingiverse/Printables. So it's not something I'll be designing on stream today, I don't think. But I wanted to walk you through that as a design consideration, because that's something that you are going to need to think about when you run into problems like these. So, all that being said, let's go ahead and get on with the main show, which is getting the size of this M5 nut so that we can incorporate it into the design as a capture nut on the Gopro style mount 0. Alright, 7.8 we'll call it. And again, I'll do my 0.05 for 3D printing. We'll take you back over to Fusion. I just said 7.8. Don't let the Alzheimer's kick in. Oh, you silly. Alright. D 7.8. So there's that. Do I need to... yeah, I will. I toss these around here. That way I can offset this and that. It's one of those things. It's not really... I'm not terribly concerned about it. I might just go 2 instead of 3 on the walls here. And then, again, I said this was 8, if I recall correctly, which doesn't look bad. Yeah, 8 to the center of that does not look bad. I talked about doing 8.5, but probably unnecessary. Alright, so this is our hole here. We need to be in front of that hole, so let's go ahead and draw another construction line here. Make that, whoops, not locked. Unlock that guy. Don't do that. I want that perpendicular. Make that perpendicular, make that tangent, and make that quinkadink. So there's that, and then I said that we'd go ahead and keep the same nifty design here with the tangent on that. Probably unnecessary. Looking at it, it's probably definitely unnecessary, but we're going to keep it in there anyway. So let's go ahead and extrude this out. This is going to be the center one, so we won't be extruding the hex on this guy. We'll turn the body back on, and we want a symmetric extrude. And we said this was 1 divided by 8 times 1 inch. And get rid of those suggestions. And then we are going to pattern this out. I think we're going to pattern this out. It's one of those things. There's a couple different ways to do it, but I think pattern kind of makes the most sense. And I should be able to just use that line as it. So let's go ahead and grab this feature. Grab this feature. Use this line. Yeah, alright, we're using that line. And now, start point, let's symmetric spacing 1 divided by 8 times 1 inch. That's times 11 inches. Make that a quarter. We'll make that a quarter. Now we should have 1/8 of an inch between each of these. And you can see how we're falling off the edge here. And I saw that was going to happen when I drew the box. And I'm okay with that. So we're going to go ahead and allow that to be what it is. And we should be good. One interesting thing to note. This starting point, if you're not familiar with it, let's see if I can't get the hover dialog up. It's really annoying when you're trying to figure things out. Basically, it should only ever be 0.5 or 1. I don't know why it exists as it exists. I don't know what exactly it provides. I mean, you could probably show me. Honestly, somebody could probably show me, oh, here's one obscure situation where you want to offset by 0.25% because it only goes between 0 and 1, going above or below 0, above 1 or below 0. I'm pretty sure always provides an error. So it's always a 0 to 1 inclusive. And in that case, you know, it's one of these things. What I'm basically getting at here is I kind of almost feel like the start point might be better off instead of being a percentage of the feature, instead being an actual number, an actual unit. So for example, we're at 0.5 right now. If I could make that 1/4, have my starting point be at 1/4 or 3/16, it might be 3/16 might be the correct thing to call this right now. You know, that would make more sense because then I could say, you know, 1 divided by 8 is my thickness, set that as a parameter, and then 1 divided by 8 times 1.5 gives me my starting point. It's one of those things. That's basically what I'm getting at. Is it's easier to use if it was something other than this random percentage here. And that's a bit of a rambling anyway, so let's go ahead and get that cut. And then we will go ahead and come back to this pane. And I will throw another circle in to this guy. And what we can do is extrude that. Let me hit the finish sketch button first. That way we're at the end of this timeline. And we can go ahead and extrude this. Wrong button. All flip it. And that will go ahead and cut everything to that lip. You see? And that is that. So now we just got to draw the extrude rather the hex nut shape out. And I will do it like that from object. And it's one of these things. If I look at this as the front, which side is actually the front here? The front may actually be the flat side. The flat side may actually be the front. And if that's the case, then it's on the left-hand side relative to the flat side. So let's come over here, there. And what's the thickness of my hex bolt? 3.845 is what I got on the calipers. Minus 3.85, I'll call it. And join. And what they did here, which I agree with, and so there's a couple, there's other ways I've done this. So let me just show you this really quick. This is one of the ways I've gone about this. I'll put a plane in here somehow. Plane through 2 edges, let's do. Okay. So I have, in the past, in order to get up to this part, actually no, sorry, that was the wrong one. I've done it this way. Sorry, I'm going insane. No, I did do it the other way. So, there we go. I believe I've done it this way. And I've taken, not a projection, but an intersect of this and that. And then drawn, let's get, I've done something to the effect of this before. Where I go ahead and give myself the, on the other side, my 60 degrees right here. And then extruded that out. Again, it was something to this effect is what I did on my other design. But the point being is that what they did on theirs, and is frankly easier to implement, is just well, this looks more like a fillet to me. is what it looks like, but I'm going to go ahead and chamfer instead. Done this. Okay, so obviously that is not working. So there's a couple different things here. I can go ahead and chamfer from both sides. So chamfer this out. So we can go ahead and do that. And then chamfer the other way to get us the rest of the way for these print overhangs. 1, 2, 5. Figure out what the correct number is that it likes. 0.3, 0.4, 3.9, 3.7, 8, 5. All right, cool. So that's one option for dealing with that overhang. Actually, I kind of like that. I think that's how I'm going to keep it. So that gives it a nice curved look. Again, before on another design, I basically just made a triangle shape and extruded it out. And I can't remember how exactly I did it. I did it in some manner such that I think I might have had a reference plane or a reference sketch in this direction that gave me 2 points. And then I connected those 2 points, which would be up here on this plane that I was sketching on. Instead of being down here where I actually connect the triangle, they would be up here. And then I extruded it so that the triangle started, say, right here and extended to right here. Anyway, point being is that's another idea of how to overcome these overhangs right here. And again, the overhangs on the inside of the screws don't necessarily matter. So that concludes the GoPro mount. Let's go ahead and take a quick look at it on the rest of the base. Top shell. Yeah, so if the phone is over here and leaning backwards, leaning in line, parallel with these guys, let's say, then that's over top of the center of the Lazy Susan, so that's cool. If it's not, if it's leaning the other direction, then that does pull the Lazy Susan. So in other words, you're watching your phone from this direction and therefore it is leaning back this way. If you're watching your phone from this direction, then that is, off centering the Lazy Susan. But it's probably one of those things where, unless you got an iPad on there, unlikely to flip the Lazy Susan over. And we have solutions that I hope to get to in this video, but we are running a bit long. So one of these things, where do I want to stop is the question. We gotta, it's one of those things. I don't imagine, I'm looking at, we've been running for an hour and a half now. I don't particularly mind going 2 hours, but at the same time, I don't know how much more we get done in 2 hours. So, let's just go for the 2 hour mark. Again, I don't particularly mind going for the 2 hour mark. It's just a matter of, it may take another hour after the 2 hour mark, so we might be up to 3 hours in order to actually get this done. And I'm not in that much of a rush to get it done because, again, project ends in, I guess, about 8 days now, I believe is what our countdown's at. So we still got plenty of time. And yeah. Once we're done this, we're done this. So if I spend another half an hour right now and we're not done the phone mount, it very well be, again, another hour stream to finish it up, and an hour stream is plenty. Well, I shouldn't say plenty. Obviously, there are people who stream a lot longer than this, but an hour stream is satisfactory to me for a design stream. So let's hop back in here. That is the front, and yeah, okay, so we will now hop over here. So obviously we started designing this for our natural, what I'll call it, our natural mount, our proprietary mount, whatever the heck you want to call it. but we are not designing for that at that point. So, how... I'm not sure how that comes through on the mic. Oh, now I'm yawning. Okay, I just looked at the time and now I'm yawning. That's great. Basically, what I'm thinking is back to the boundary fill. We may want to just ignore this part right here. Let's bring the bodies up. We may want to delete this part for right now. Delete all this. Yes, that affects our sketch, I know. And just draw the phone mount. Just free floating in space, and then align the boundary fill the phone mount into a GoPro phone mount, and then align that with the GoPro mount and make the hinges at that point. That may be the best course of action for us. So I think that's what we're gonna do. And boo. Is there anything I want to change here while we're talking about it? Oh. No, I don't think so. So let's grab a reference point just so that this is not blue and this is black instead. So it's constrained is the correct word I'm looking for. Let's just center it on this random origin point right here. Now, I said 60 and 90. If I recall correctly, it doesn't look like I actually wrote it down, so let me just write down 60 and 90 for future reference. Min open, max open. Cool. So, if that is the case, we are going to want some degree of overlap between the bottom piece and the top piece. So let me just draw a rough, again, these are rough right now. We're going to want some overlap here to add stability to it, to add meat to it, so that it doesn't twist around and stuff. So we got to decide what that is. If we call that an inch, we call that 25 millimeters. I'm going to go ahead and write that down. So if we have 25 millimeters off of, let's say, the 90, because the 90 is going to be our biggest opening. Yeah, I should be fine taking off the 90. So 90 minus the 25 would get us to 65. I have to do math on paper now that I'm streaming, because again, that whole debacle that I still haven't got over with the gear ratios is traumatizing. So 65, and then we divide it is the distance. I did this wrong. I'm glad I wrote this down. It's 90 plus the 25. Good bunch of men. All right, 115. Right, 115. Yes, 115. So 115 is our total amount of plastic. Nah. Okay. I'm still doing this wrong. Wow, okay, maybe I haven't been streaming too long. Alright, let's bring you back over to the camera so that you can see me screwing this up in real time. So over here is where I was screwing it up. Let me use this picture of our phone mount to demonstrate. So our overlap here. This is our overlap, this box right here. This is going to be 25. So this overlap of 25 is actually 25 on both the bottom and the top. So if our max opening size is 90 on the inside, this is 90 right here. I divide that in half to get 45. And then I have to add 45 to a full 25 instead of dividing the 25 in half afterwards, which is what I was doing down here. X that out. Now we get 70. So each of these segments need to be 70. And that's going to be 45 from here to here, plus a 25, 45 from here to here, plus a 25 in the middle to get us to the 70. There we go. Now we know what our numbers are. And switch back to Fusion. Alright. So let's get that mocked up. So on the inside here is what I was saying. That needs to be 60. Whoops. Why are you over constrained? Oh, is this one of those situations where Fusion is not showing me all my numbers? No, it doesn't look like it. Oh, it's because it's offset. That is why. So because this offset is running here, it's looking at this and it's like, you can't do that because that's an offset. You're taking dimension between an offset and a... Alright, whatever, Fusion. Don't be silly. Fusion, frankly, you should know that this distance right here, which is I'm calling 65 minus 3, that's how you would do that math, Fusion. I realize that you're a little slow, Fusion, but that is how that math works. You know that this offset is here for 3 millimeters, which means that any distance, which means that this arm is necessarily... I know, I'm complaining. I'm complaining a lot today. Alright, next thing we got to do is figure out how much meat we need here for a phone. So I'm just going to measure my phone in this case really quick. This OtterBox. Actually, I don't think this is an OtterBox. I think it's an off-brand. Regardless, I'm getting 11.5. So if we call that 12 to be safe, do we want to call it 12 to be safe? Do we want to call it 13? 12.5 would be half an inch. If we call it 13, let me look at, because my case is a little bit, might be a little bit bulkier on the S7, even though the S7 is thinner. Yeah, it is. So you can see this. I had this wallet case for my S7, and obviously that is a lot of fabric in there. So I'm going to go ahead and measure this guy instead, and then add a little bit to this guy. So this guy is already, if I'm trying not to squeeze him, he's something like 18 already. So if we call this 20 on the inside, that should be fine. And it's one of those things, we can go ahead and maybe put a little bit of a curve or something like that. So at the bottom here, it'll be 20. But at the top over here, or at the top over here rather, it'll be like 20. Yeah, let's do that. Let's do that. I like that idea. So we are going to draw an arc in here. Arc, and I think a center point arc. Whoops. Nope, not like that. I do want a center point. Oh, no, tangent arc should be fine. Right? Yeah, tangent arc should be fine. Cool. So let's do that. And then we'll just extend this out and perpendicular that. Actually, let's not do that. Let's do that and then that, so that we have some thickness here. That thickness will be... let's not do that thickness until I get it constrained correctly. Perpendicular, perpendicular. And now we can do wall thickness there. Cool. Alright, so at this point, which is the furthest point. Okay, Fusion. Oh, burr, 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 burr. Don't be a doofus. Wait, is that... Are you not square? Okay, you are now square. And you are going to go ahead and be vertical. And what else is not constrained around here? Undo drag. Let's see if we can do this. Okay, we can do that. All right. So we need to subtract 2 wall thicknesses, 2 times wall thickness. So that's this wall thickness here and this wall thickness here. And then we want the inside here at this furthest point, which is these wall thicknesses here, to be, let's call it 21. Plus 21. Okay. Fascinating. Okay. Let's... You... how do I go about this? Basically... You know how I said minus? I want to add 2 wall thicknesses. Cool. Let me just double check this. This should be 21 now. It is 21. Okay. All right. Back onto what we were dealing with before. So this, let me do this. Throw this construction line in here. This is the way I'm thinking of fixing it at the moment. Just making this tangent so that, yeah, that works. So you see how that is always straight up at that point? Now, what else is changing here when I do this? Obviously, it is... Oh, okay, just the curve. The position of the curve is changing. Took me a minute to figure out what exactly was changing here, but how deep this curve is changing when I change the depth here. So the question is, between here and here is going to be 21, which is the thickest that we're making this. So if that's 21 there, the smallest doesn't necessarily matter, right? So can I even constrain that? I can't constrain that. So what we may just want to do is we might just want to constrain this and call it a day. And how much do we want? Probably a 1/4 inch is probably fine. So something like 6-7 millimeters. So a depth of 6 or 7 millimeters here maximum. It's one of those things. This is in theory going to be clamped in, and we can always make changes later. So I think that's what I'm happy with. Okay, so one thing to mention here is that this is not a good design for printing because we are intending to print it laying down like this. So this lip that I added in here to kind of cup the phone, which is my idea, doesn't print very well. At least with that much overhang. And we can fix that. We can fix that by deleting this. Not radius. That and that. No, not that and that, because that is guaranteed to be 90. Okay, yeah. Now that I add in this line, this is always like that. So what we will do is, well, that's going to be perpendicular too, right? No, okay. So basically what I'm trying to do is get this angle here, which that should be fine, and we want this to be no more than 60. 60 being a good angle for the overhang. So that is what we're going to do. Now, what can I adjust here? Okay. So we can make this dip a little bit bigger. So back to, I called this 7 before, right? Yeah, and now Fusion doesn't want to allow me to do anything with it. Typical Fusion. It's one of these things where... Alright, you know what? I have decided that I like it like that. Now, the last thing I am going to do here, and then we are going to go ahead and be done for today, because obviously I am losing energy. Well, you know what? I don't even think this would be a problem if I was losing energy. I could probably power through it. It's just that I don't think that we're going to get nearly as far done as I would like to get right now. Basically, where all that was going was we're going to put a opposing arc in here. That way it's got a little bit of aesthetic pleasure to it. And now we will go ahead and extrude our masterpiece. And we'll symmetric extrude. And let's see what on my phone looks like a good amount of thickness to be holding the phone by. I'm going to go with 2 inches, about 50 millimeters. So let's extrude that 50 millimeters. And that will be good. Okay, and again, kind of basic right now. I might come back in and adjust this, but until we have this set up so that it's actually feeding into the top part, we're going to just leave it like that for today. We have the base done here, so let's go ahead and turn the other thing on really quick. And we're not aligned, so I guess it doesn't actually matter. But I just want to have a full picture for aesthetic reasons. So that's where we're at. So this will be picked up, placed on top of that GoPro. We will make the top part, which is going to look extremely similar to this, to the bottom part. And then we will do the attachment system for keeping it down. And again, as noticed, or as noted in the very first episode, I'm going to do that with a rubber band on this version. You can also do it with screws. You can do it with springs. You know, anything, just keep it down. So that concludes this design live stream. Thank you all for watching, and thank you for any support that you're giving me in the future, because frankly there ain't nobody here right now. But I'm very happy with how this is coming along. Obviously this did take me longer to put together today than expected. I was thinking in an hour we might already have the top piece done. We're nearly 2 hours at this point, and we haven't even started on the top piece. So my expectations were a little off. We had a couple little hiccups, but that's not that big of a deal. Otherwise, again, glad to be doing this. I think we're taking this in stride, and we're going to get there eventually. I don't think we're running up against the deadline anytime soon. I think we're actually still have a bit of leeway and don't need to be rushing anything. So feeling pretty good about this all. So thank you again, and as always, have a great and wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.